So we've got Spearman's rank question from the stats workbook, and we've got this plant here, the purple loosestrife, and we've got beetles, and we've measured how many plants we've got and how many beetles we've got in a meter squared of area. I'm looking to see if there's any relationship between them. First of all, are we doing the right test? And are we looking for associations between them? So whether they're correlated, yes. Are we looking at a difference between two means? Pointless, mean plants and mean beetles. Or do they fit into categories? No. So we're doing the Spearman's rank correlation here. So we're doing the right test. If I quickly do a graph of this, just to show you what sort of thing we're looking at. So here we've got purple plants, whatever they are, purple loosestrife, and we've got beetles there. And our data for plants goes up to about 30, so 5, 10, 15, 20, 25, 30. Beetles goes up to about 70, so 10, 20, 30, 40, 50, 60, 70. And our data is 28 and 4, 22 and 5, 8 and 40, 6 and 62, 7 and 68. And if we had to sort of draw a, I don't know, correlation, that would be a negative correlation. So it'd be less than 0, so it'd be minus something. So that kind of looks all right. We haven't got many data points. N is 5, which and so is our correlation with those 5 points good enough? And that's what we're going to look at. So we think it's a correlation, but with our 95% confidence, or p is 0.05, is that good enough? So here we go. Our null hypothesis is that there's no correlation. So our null hypothesis is basically that there's no correlation, or these aren't strong enough. So there is no correlation between purple loosestrife plants and the number of beetles. And what we want to do really is, if we've got good data, we're going to reject that. And first thing we need to do is rank the data. So here's our first set of data for plants. And we are 28, 22, 8, 6 and 7. So let's put this down here. So 28, 22, 8, 6 and 7. The rank, we're going to give the highest number, so that's our highest one. We've got 5 bits of data, so 5, 4, 3, and these two are the wrong way around, so 7 would be 2, and then 6 would be 1. Okay. We need to carry these numbers across for beetles, so the same again, 4, 5, 40, 62, 68. We can't change that order. We've got to keep in the same order as the plants. Ranking the beetles, biggest one is 68, then 62, 40, 5, and 4, 1. Okay, now we need the difference between them. Should be able to do these in your heads. The difference between the ranks, the difference between 5 and 1 is 4. If you want to check that, 5 minus 1 is 4. Yeah. The difference between 4 and 2 is 2. The difference between 3 and 3 is no difference at all. The difference between 1 and 4 is 3. And the difference between 2 and 5 is 3. You could put some minus numbers in here, but as we're going to square it, those minus numbers are going to disappear. So minus number times a minus number is a positive number. Square, so you can even do these in your head. 4 times 4 is 16, 2 times 2 is 4, 0 times 0 is 0, and 3 times 3 is 9, and 3 times 3 is 9. Add those together. 16 plus 4 plus 0 plus 9 plus 9 is 38. So that's the sum of the differences squared. Right, so sum of differences squared, that is this thing here, so that is 38. And n is our number of samples, so n is how many of those we've got, which is 5. Now we are putting our numbers into this equation. So we've got Spearman's rank, that's RS there, equals 1 minus, and then let's put some things in. So 6 times the sum of the differences squared, which is for us 38, and n is 5, so 5 times by 5 times by 5 minus 5. Equals 1 minus, I'm just doing this step by step, so 6 times 38 is 228. 5 times 5 times 5 is 125, and take 5 off that, 120. So now it's 1 minus 228 divided by 120 is 1.9. So 1 minus 1.9, 1 minus 1.9 is minus 0.9. So Spearman's rank is minus 0.9. Minus 0.9 there. So that's the calculation. And now we need to interpret our results. We need how many, what's our critical value? So our critical value is dependent on our number of, let's just find, I've lost the chart now. Here we go. So if we've got 5 pairs of measurements, our critical value is 1.00. So our critical value is 1. And now we just need to go, our calculated value of Spearman's rank is it smaller than bigger than critical value? So it is 0.9, is that bigger or smaller than 1? So ignoring the minus. So that is actually smaller than 1. 0.9 is smaller than 1. And then we need to go, in that case, there's more than 5% probability that the negative correlation, remember we've got a negative correlation here between whatever it is and whatever it is. So loosestrife plants and beetles is due to chance. And so unfortunately on this occasion we're going to have to accept our null hypothesis. So that means there is no correlation. So even though we thought there was a correlation, because our number of samples is only 5, then it means that it's very difficult to get a significant result.